Hello friend, I am Somadeep back to with new tutorial video regarding IS456-2000. In my last two videos, I talk about the general concept of the IS456 where I talk about the mix design, where I talk about the terminal state. So in case you didn't watch this my last two videos, so there should be some I button or you may find here playlist. Just go and check out the last two videos. So in this video I will talk about the section 3 general design consideration. Yes, this is our topic, the general design consideration. Yeah, video should be long, maybe long, should be long. So if any kind of doubt, do comment in comment section. Otherwise, let's get started. So first we talk about the aim of design. Okay, aim of design. What should be our aim? Why we do the RCC? What should our objective? Aim should be achievement of the acceptable probability that structure being designed will perform satisfactorily during the entire life. That is the first point. Aim adequate safety. Okay, with an appropriate degree of safety. That is why in the limit state method there is a two kind of safety. One is safety factor, one is material safety factor. Okay, and then should sustain all load and deformation of normal construction and use have adequate durability. Number two, restricted deflection. Restricted deflection, that should be restricted. And number three, there is proper, that is durable. So these few things are our aim of the RCC member. Okay, an adequate resistance effect of misuse and fire. Obviously, within durable, this fire risk comes. Method of design: the structure element a normal design. Yes, limit state method. Before 2000, we used the WSM. After 2000, we use the LSM. WSM means working stress method. LSM means limit state method. Okay. Account should be taken of acceptable theory, experiment and experience and the need of design for durability. Calculation alone do not produce safe, serviceable and durable structure. Suitable material, quality control, adequate detailing and good supervision are equally important. They are saying that suppose I am designing very safe. Okay, design is okay. But if material is not okay, quality control not okay, you do not supervise properly. Supervise matlab you do not check properly, you do not check the spacing, you do not check the covers, you do not check the proper vibration is doing or not. So these also comes under the supervision. Okay, so if these things are not proper, then our whole structure is not safe. So this is all are the equal important. If these all are properly checked and properly okay, they if and only if, then our structure is okay. So that is the method of design. Where the limit state method cannot be used, we can use the working statement, but definitely you should take permission from your engineer in charge. Not like that you go side, okay sir limit statement काम नहीं हो रहा है, so we'll go and we'll do the WSM. This ये कभी नहीं हो सकता है. Okay. Design based on experimental basis. Design based on model of full size structure element. No need of that. Okay. The structure shall satisfy the requirement for the deflection. Yes. As well as cracking. When subject load is 24 hours of a characteristic load multiplied by 1.33, where YT shall be taken as table number 80. We will talk about that. For a limit state of serviceability, if within 24 hour removal the load of structure does not show a recovery at least 75%, same thing I talked about the last video. The structure shall have adequate strength sustained 24 hours, a load equal to characteristic load multiplied 1.33. Why 1.33? It comes under the partial safety factor or safety factor. But when we do, there is no 1.33, there is a value called 1.5. Durability, workmanship and material. It is assumed the quality of concrete, steel and other material and the workmanship as verified by inspection, safety, service and durable. Design, load and forces. Now we'll talk about load. How many types of load are there? One is dead load, one is life load, one is your wind load, another is your earthquake load. Dead load shall be calculated on the basis of unit weight, which shall be established by taking into consideration material. Yes, this is for PCC 24, for RCC 25. Dead load for PCC 24, RCC 25. Okay. Imposed load, wind load, snow load should be IS 875 Part 2, 875 Part 3. If you do the calculation in the mountain region, snow region, there should be IS 875 Part 4. But earthquake load, there is a code IS 1893. Okay. Shrinkage, creep and temperature effect. If the effect of shrinkage, creep, temperature are liable to affect material, the safely serviceable calculation of 875. The effects due to temperature fluctuation and shrinkage, creep can be ignored in design calculation. Other force and effects: foundation movement, elastic axial shortening, soil and fluid pressure, vibration, fatigue, impact, erection load, stress concentration. These are comes under other forces and effects. Suppose this is your home, and from this side go the NH, and this side say somehow go metro. So when metro is passing, when some truck is passing through the NH, then definitely your foundation you feel some vibration. Your foundation is vibrating. So these the other forces which comes under the circumstance due to circumstance. Now we talk about the commission of the load. Okay. Why commission load? Actual, suppose design load equal to, there are some combination, either dead load or live load, either dead load, live load, wind load, either dead load, live load, earthquake load. So these are few combination. So we'll talk about that. The combination load as per given IS 875. So this is called combination. This is called combination, and you will find this combination from IS 875 Part 5. Dead load counteracting other load and forces. When dead load counteract the effect due to other load forces structure member of joint, special care shall be exercised by the designer to ensure adequate safety for possible stress reversion. Stress reversion, that means, I'll give you some examples. Suppose this is your a beam cross section. Here compression, here tension. Due to some environmental some issue, this portion will be tension, this should be compression. This is called stress reversal. Okay. Design load is the load to be taken for the use in the appropriate method of design. It is characteristic load in case working stress method and characteristic load with appropriate partial safety factor or limit state method. So design load is characteristic load for WSM. If this design load multiplied into partial safety factor, then this comes under limit state method. Okay. Stability of the structure, overturning. From here, sometimes they ask question in MCQ. I will talk about that. The stability of structure as a whole against overturning shall be ensured so that restoring moment shall be not less than sum of 1.2 times. From this line, exam should ask you question. Maximum overturning moment due to characteristic load, dead load 1.4 times. Okay. In case where dead load provide the restoring moment, only 0.9 times the characteristic dead load shall be considered. Restoring moment due to imposed load shall be ignored. The anchorage of counterweight provided for the overhang member should be such the static equilibrium should remain, even the overhanging moment double. The anchor of counterweight provided for overhang member. That means, as I will talk. Suppose this is your last beam. And here is some overhanging portion. So for this overhanging portion, one anchorage will be done. That's why they told them till here the anchorage of over counterweight provided for overhanging member during construction and or service. Service means when we stay in the apartment or a no structure. Should be such that static equilibrium should remain even when overturning moment is double. Static equilibrium means that is all static equilibrium equation, that is the Rx Ry moment that equal to 0 summation of this. Okay, sliding. Sometimes they asking question from here also. The structure shall have factor again sliding of not less than 1.4. 1.4. Most adverse combination, the characteristic force in case of 0.9 times. Probable variation of dead load. Ensure stability all time account shall be taken. Moment connection, no issue. Yes, lateral sway. Under transient wind load, the lateral sway at the top should not be exceed h by 500. H is the total height of the building, and that is reference is IS 1893. Fire resistance, just know about this code, otherwise I never seen any question regarding this. Yes, fire resistance, for if you consider the fire resistance, then should be there is some clear cover exceed 40 mm for beam and 35 mm for slab if you are designed for fire resistance. Now we talk about the analysis part. So first is effective span. What is the effective span? For simply supported beam. So first I draw the simply supported beam. The effective span of member that is not built integrally within support shall be taken clear span plus the effective depth of slab or beam. Suppose this is your clear span D, sorry L, and this is the depth. Then effective should be L plus D, or beam or center to center of the support, whichever is less. Sorry, that is the clear span, plus or C center to center, which is less. So this is your effective span for beam. When I show you the design part, you can understand clearly. Continuous slab. In case of continuous beam or slab, if the width of the support is less than 112 or the clear span, the effective span shall be 22.8. 22.8 means this is 22.28. Less than 112, then will follow this. Otherwise, if the support wider than clear span or 600 mm, whichever is less. For end span with one end fixed and the other continuous, for the intermediate span, the effective span shall be the clear span between two supports. For end span with one end free and other continuous, effective span shall be equal to the clear span plus the half effective depth. In case of span roller or rocket bearing, effective span shall always be the distance between the center of the bearing, ultimately center to center. Cantilever. Effective length of cantilever beam shall be taken as the face of the support plus half of the effective depth, expect. So suppose this is your cantilever. What they say? They say about length, the face of the support. Face of the support, this is L, and the half of the effective depth. If this is D, then L plus D by 2. From end continuous beam where the length centers. Structure frames no needed. Imposed load. Suitable frame, no need of that. Moment of shear coefficient. Yes, this is very important. The beam and the slab over the free end. A member built in the masonry wall which develop partial resistance, the member shall be supported WL by 24, where the W is the total design load and L is the effective span. Such other restraining moment as may be shown to be applicable. For such a condition, shear coefficient may be given in table 13, end support will be increased 0.05. That means, suppose your member is built on the masonry. Suppose this is your masonry structure, and you do some slab or beam here. So in this space, there is occurring one load, that is WL by 24. Yeah, yes, that is the table, and that's also table for shear coefficient. Critical section for moment and shear. The monolithic construction, the moment computed at the face of the support shall be used in design the member. Those section for non-monolithic construction, design of the member shall be done in keeping 22.2. 22.2 means critical section for shear. The shear computed at the face of the support shall be used in the design of the member at the section where the reaction in the direction the applied shear introduce compression into the end region, the member section distance less than d. From there, some in you find a question in some exam. Redistribution of moment. Redistribution moment may be done in accordance with 37.1.1 for limit check method and accordance to 12 where the simplified analysis using coefficient is adopted. Redistribution moment shall not be done. So when you talk about 37.1.1, then you find how to moment should redistribute. Actually, we find this moment distribution in the moment distribution method. We'll learn in the structural analysis. Now we talk about the beam. Now, what is the effective depth of beam? The effective depth of beam is the distance between the centroid of the area of tension reinforcement and the maximum compression fiber, including the thickness of finishing material, not placed monolithically with the member with thickness any concrete provided to allow to wear. This will not apply the depends. So distance between the centroid, the area of tension reinforcement, effective depth, and the maximum compression fiber. That means, simple language, this is a beam cross section, and here you provided a bar. This is your extreme compression fiber. Extreme compression fiber. This is the centroid area. This is centroid area. This is centroid. So from these to these, this is your effective depth. This is your effective depth. But for T beam and L beam, there is some formula. This is formula for T beam and L beam, and this is also. One is for isolated beam, one is for continuous beam. Now we'll talk about control of deflection. This control of deflection, this is very much important. Cantilever simply about now. Your favorite zone where you find question from IS456. Okay, before saying this, there are another two things. Final deflection due to all load, including the effect of temperature, creep, and shrinkage measured from the cast level, should span by 250, and shrinkage after the partition and the application finish should not normally exceed span by 350. In the West Bengal PSC Junior Engineering exam, they are asking this question repeatedly, alternative way. But and now we talk about this. But this is happen only span up to 10 meters. But when span is more than 10 meters, what will do? Multiply it by 10 by span. Suppose here is 12 meter. Then what happens for simple support? 20 into 10 by span. 10 by 12. So that will be answer. 200 when 16 point something, 16.66. Okay, depending on the area, there is a four correction. Okay, that will talk about the modification factor. Is this is just some correction. There is one correction when this will do when we do the RCC design. We'll apply the correction. Another correction is this correction. Another is this correction. But mostly we'll do this correction. Mostly deflection correction. If there is some issue in the deflection, suppose your deflection should be for simple order being is 22, then we should need correction, and we correct it in this way. Now slenderness limit for beam is 60 b or 250 b square by d, but for cantilever 20 b and 100 b square by d. Now we'll talk about the solid slab. For solid slab, the cantilever, I mean to say deflection control is 35 and 40. For high, if you use the 415 and above, multiply it into 0.8. This is for the NS. For here, nothing is so much important. Yes, this I will say very important. This is the kind of load transmission. If this is a slab, then if there is some beam, suppose I will draw here. This is your slab. So this is a slab. So here what happened? The load transmission should be like this. This portion comes on this beam. This portion comes on this beam. This portion comes on this beam. This portion. These load are transferred by this beam one. This portion of load comes under this. This portion of load comes under this beam, and here this one. Okay. Here is there anything? Okay, in next video I will talk about the compression framework. Okay, but still if there is anything I will discuss. So yeah, this is all about the video where I discuss about the section 3 general design consideration. So I try to explain the clause wise but concept wise. So if there are any kind of doubt, definitely do comment in comment section. I will definitely get back to you. And for next video I will talk about I will start the compression member. So yeah, thank you for watching this video. If you find any kind of value from this video, definitely share, subscribe and comment the video, and for notification purpose you definitely press the bell icon. Thank you for watching this video.